So the second topic in fourth module is functional dependency. Let's try to understand the term functional dependency. Consider this schema. You will be seeing something like FD1, FD2 and FD3. FD stands for functional dependency. So a functional dependency is a constraint between two sets of attributes from the database. What does this mean is, let's take FD2 to understand this. SSN gives ename, which means if you know the SSN value of a particular tuple, you can also know what is the corresponding employee name. Or ename, we say ename is functionally dependent on SSN. Similarly, if you know SSN and P number, SSN value and project number, we can know how many hours that particular employee is working on that project. Or we say this hours is functionally dependent on SSN and P number. Similarly, if you know the project number, we can get to know the project name and project location. So we can say P name and P location is functionally dependent on P number. So the next thing you need to understand about functional dependency is, say X gives Y. X gives Y is represented like SSN gives ename. That is equivalent to X gives Y. So the constraint is that for any two tuples T1 and T2 in R, where R is the relation, if we have something like T1 of X equal to T2 of X, then we should be having T1 of Y equal to T2 of Y. What does this mean is, say, let's take FD2 itself. Say SSN1 gives name XYZ. If there occurs another SSN with value 1, the name ename should be XYZ. So if T1 of X is equal to T2 of X, so T1 of X is 1, that is SSN is 1, and another tuple also has SSN 1, then the Y part, that X gives Y, that Y part should also be the same. So if there are two projects with, say, one project number is 5 and its P name and P location is XYZ and Mumbai, if another value 5 occurs, its P name should be XYZ and P location should be Mumbai. Now if that is not the case, say since SSN is the primary key or candidate key in this relation, there cannot be two tuples with the same value, right? Two tuples cannot have value SSN1. So in that case, if a constraint on R states that there cannot be more than one tuple with the given X value in that relation instance, then that X is the candidate key. Such values or such attributes are termed to be the candidate keys. And in this relation, SSN and P number are the candidate keys. And K is the key of R, then K functionally determines all attributes in R, which means all the attributes in the relation can be obtained from the primary key. Like say SSN and P number gives us the number of hours. SSN gives the name of the employee. We get to know the name of the employee from SSN, and from project number we get to know the name of the project and the location of the project. So actually from these two we can get to all the attributes. So primary key actually leads us to all the attributes. There are certain features of functional dependency listed in your notes. You may just read those features. Next thing we need to understand is a term known as closure. So we denote F as the set of functional dependencies that are specified on relational schema R. So the F in this case is SSN P number gives hours, second F is SSN gives ename, and so on. So those things are directly given, and there are some other functional dependencies that can be inferred from the given functional dependencies. And the concept of closure formally defines all possible dependencies that can be inferred from the given set F. You might have heard of this term closure in discrete mathematics or some mathematics subject. So let's take an example to understand what closure is. So another example, this was the same example which we used to describe guidelines of database design. So SSN gives ename, birth date, address and D number. Okay. And it's from the D number, actually this is the join of two tables. From D number we can get to know the department name and manager SSN. But it is clear that since SSN leads us to D number and D number leads us to D name and manager SSN, if we know the SSN, we can know the D name and D manager SSN also. You might have learned rules like if A gives B and B gives C, we can say A gives C. So in this, the given functional dependencies where SSN gives D number, another dependency that was given was D number gives D name and D manager SSN. But we could infer a new functional dependency from these two. That is SSN gives D name and D manager SSN. So the set of such newly inferred or all the inferences that we can make from the given set of functional dependency is termed as the closure. So formally, the set of all dependencies that include F as well as all dependencies that can be inferred from F is called closure of F, and it is denoted as F plus. F, it is superscript F actually. F, just above F you put a plus mark. So in this example, SSN gave us these attributes, D number gave us this attributes. Some additional information you can infer is SSN would lead us to these. Since A gives B and B gives C, you can say A gives C. Another some common attributes that some common functional dependencies you can infer this SSN would lead to SSN itself. D number, actually D number leads us to D name and D manager SSN. We can also say D number leads us to D name. So those are some other functional dependencies. So now there should be some systematic way to reach or to collect all the dependencies or all the inferred dependencies, and such a systematic way is using a set of inference rules. Let's see what these are. You might have already learned this inference rules as part of your set theory or discrete mathematics and all those things. So using this 6 inference rules IR1 to IR6, we can actually infer all the functional dependencies from a given set of functional dependencies. Let's have a look at the rules one by one. IR1 is also termed as the reflexive rule. It states that if y is a subset of x, that y subset of x, then we can say x implies y. Let's take an example. Say in this case, D number gives D name and D manager SSN. From this, we are saying that D number gives D name also, where D name is a subset of D number. So we can say D number gives D name from this given functional dependency. Such a thing inferred comes under this reflexive rule, that if y is a subset of x, then we can say x implies y. And such rules at all, this IR1 is the reflexive rule. Such rules are termed to be trivial. What trivial means? They are always true. So just reading out the statement states that a set of attributes determine itself or any of its subset. And since this IR1 reflexive rule generates dependencies that are always true, such dependencies are called as trivial. So something like SSN gives ename belongs to IR1. SSN gives birth date belongs to IR1 because ename and birth date are already in the subset of SSN. The second rule is if x gives y, adding an attribute to both the sides, xz gives yz. That is the second rule, augmentation rule. The third rule, which is the most common one, if x gives y and y gives z, we can say x gives z. That is the transitive rule. Then the fourth rule, That is, if x gives y z, we can decompose that and say x gives y and x gives z. Then this union rule, if x gives y and x gives z, if we take the union of these two, we can say x gives y z. Then there is pseudo-transitive rule, which is actually derived from the transitive rule, which says if x gives y and from this y we are adding w to y and wy gives z, we can say wx should be giving z. So these are the 6 inference rules using which we can actually infer all the functional dependencies from a given set of functional dependencies. Now the next thing we need to understand is the inference rules IR1 to IR3, that is this reflexive, augmentation and transitive. These 3 rules together are termed to be the Armstrong rules. Armstrong was the person who found out these 3, and we say these rules IR1 to IR3 are also termed to be sound and complete. Sound and complete means we can actually infer all the set of dependencies from these 3 rules alone, IR1 to IR3. Using these 3 itself, we can actually derive all the existing dependencies. This IR4, IR5 and IR6 are actually just an extension of IR1 to IR3, and this can be easily proved. I think you might have already learned the proof of all the rules. So IR1 to IR3 are known as Armstrong rules, and they are also termed as sound and complete. You might get a question why, justify why they are termed as sound and complete, or which are the rules that are termed as Armstrong rules, or define all the inference rules. There are many questions you can get from this section. So that is regarding functional dependency, and using inference rules we can infer all the functional dependencies. Now let's understand the closure of a set. Closure, what we mean by closure? Closure is actually all the functional dependencies that can be inferred from a set of functional dependency. If f is the set of functional dependency, f plus is termed as the closure of f. So let's see how we can actually infer all the functional dependencies. There is a standard algorithm for that. So closure of a set of attributes x with respect to f is the set x plus of all attributes that are functionally determined by x. X plus can be calculated by repeatedly applying IR1 to IR3 using the functional dependencies in f. Let's see how we can find the closure. Let's first take an example and then come back to this algorithm. Consider this example like EMP project is a relation. In this, we know SSN and P number leads us to hours. This is the same example which we just discussed. SSN leads us to E name. So that is the second dependency, second functional dependency. Third functional dependency is P number gives P name and P location. So these are the 3 given functional dependencies. Now, let's take the first functional dependency. SSN gives E name. So SSN closure means we can actually get SSN from SSN. We can also get ename from SSN. So SSN closure would consist of SSN and ename. And how we got this is if x gives y, this x would give x as well as y. So SSN closure consists of SSN and ename. Now let's take P number closure. P number closure should be giving us P number, P name and P location. So P number would give us this 3. In the next example, we can get to know more. So SSN and P number. Let's take the closure of SSN and P number. So SSN and P number should be giving hours. It should give SSN and P number. Now SSN P number gives SSN P number and hours. So in this, we already know SSN gives ename. So ename is also added to the closure. We know P number gives P name and P location. So this P name and P location is also added to the closure. That's how we get SSN P number closure. We get SSN P number hours, which is already given. SSN and P number gives hours. SSN P number should be giving SSN and P number also. In addition to that, we know SSN gives ename, so that ename is also added to this closure. And we know P number gives Pname and P location, so Pname and P location is also added to this closure. So SSN P number closure gives all the attributes. Another thing we need to understand is, if an attributes closure gives all the attributes of the relation, that attribute is considered to be a candidate key. So in this, SSN P number is considered to be a candidate key, which can be a primary key also. So a closure of attributes which leads us to all other attributes in the relation is termed as a candidate key of that relation. Now let's see how we can find this closure using an algorithm. It is pretty simple algorithm. Initially, X is the given set of dependencies. Consider X to be the set of given dependencies that would be there in the closure. We need to repeat. There's only this one single step we need to understand. For each functional dependency, Y gives Z. Let's take an example from this. Say we are trying to find SSN P number closure. We are trying to find SSN P number closure. So in SSN P number closure, SSN and P number would be there. Since we have assigned X plus equal to X, that is SSN P number would already be there in SSN P number closure. Now what we need to do is, for each functional dependency, Y gives Z, which means consider this SSN gives ename to be equivalent to Y gives Z. Okay, SSN gives ename to be Y gives Z. So, and if this Y is a subset of X plus, so X plus now consists of what all? SSN and P number, and Y gives Z, where Y is SSN and Z is ename. So this Y SSN is already there in X plus, so we can say Y is a subset of X plus. SSN is already there in SSN P number, which is X plus. So in that case, what we can do is, we can simply add Z to X plus. So we just take union of Z along with X plus. So since SSN is already there in S plus, SSN gives ename. That ename is also added along with the closure. So that's how SSN P number closure consists of SSN P number hours, and after that ename is added. And similarly, since P number is there, P name and P location is added. That's how the closure is built upon. We can consider one or two more examples to understand this. You can expect these kind of problems for exam. Consider a relation given like A, B, C, D, E. It's a relation given. This A, B, C, D and E are the attributes. And there would be a set of functional dependencies that are given. It is given like AB gives CD, ABC gives E, and C gives A. So we need to find AB closure. Let's find what is AB closure. So from what you have understood now, you might have understood that AB closure would consist of A and B. And we know AB gives CD. So AB closure should consist of A, B, and since it gives CD, it should consist of C and D. So that much we got. AB closure now consists of A, B, C, and D. So let's take the next functional dependency. Another functional dependency, Y gives Z, is a form ABC gives E. Now this ABC is a subset of AB closure. Why? Because AB closure already consists of ABCD. So ABC is already there in AB closure. So since ABC is already there in AB closure and it gives E, we can add this E also to the closure. So now AB closure becomes ABCDE. Now taking the next functional dependency given, C gives A. So, the C is already there in the closure, we may add A, but A is already there in the closure, so we need not again add that. So in fact, AB closure gives, using AB closure, initially it gave AB. Since AB gives CD, it gives CD. Now since ABCD is there in AB closure and ABC gives E was added. So AB closure actually gives all the attributes, and we can say, so AB is a candidate key of this relation. So that's how we find closure. And if the closure of a set of attributes or of a single closure of a single attribute leads us to all the attributes, we can say that attribute is going to be the candidate key for that particular relation. Let's see another candidate key for this relation. Let's try to find BC closure. Okay, try to find it out on your own before you look at the answer. So BC closure would anyhow contain B and C. Okay, let's take each of the functional dependencies one by one. So BC closure now just contains B and C. So AB gives CD cannot be considered since we don't have A right now with us. We go to the next one. ABC gives E cannot be considered because we just have BC with us. A is not there. Going to this, C gives A. Since C gives A and BC closure already contains C, we can add A to that. So BC closure now becomes ABC. Coming back to this. Now BC closure consists of ABC, and since AB is there, CD is added. Since now ABC is there, E can be added. So BC closure would also lead us to all the attributes. So we can say that BC is also a candidate key. So for this relation, there are two candidate keys, we can say AB closure and BC closure. So AB and BC are the candidate keys. We may get similar questions for exam. So the importance of learning closure, of trying to find closure, is if a closure of a set of attributes gives us all the attributes in the relation, we can say that that particular attribute is going to be the candidate key for that relation. That's the importance of understanding or finding out closure of an attribute. Let's take one more example. Another thing given, relation given is R is a relation consists of A, B, C, D, E and F. And the functional dependencies given are AB gives C, C gives AD, D gives EF, F gives B. 4 dependencies are given. Now, don't look at this part. You may be asked, the question is determine any two candidate keys of the relation. You need to find out two candidate keys. So one clue you can get is either AB can be a candidate key, C can be a candidate key, D can be a candidate key, F can be a candidate key. All this are equivalent candidates for a candidate key. Let's see AB closure. What is AB closure? So AB closure would contain A and B, and since it gives C, it would contain C. So AB closure now contains A, B and C. Since C gives AD, A is already there, D is added. So AB closure now contains A, B, C and D. Since D gives EF, E and F are added. So AB closure gives all the attributes A, B, C, D, E, F. So AB is a candidate key for this relation. Let's see whether C can be a candidate key for this relation. Now C gives C itself and C gives AD. So C closure now contains A, D and C. Taking the next functional dependency, since ADC is already there in the closure and D gives EF, so A, C, D, EF is added. Going to the next functional dependency, F gives B. Since F is already there in the closure, we can add B to the closure. So it would consist of C, A, D, E, F and B now. So everything gets added to the closure. So C is also a candidate key for the relation. Now if you are getting a question, what would be the key for this relation? We should consider the minimal key for this relation. AB also leads us to all the attributes. C alone also leads us to all the attributes. So we can actually take C to be the key of this relation, because using a single attribute we can reach to all the relations. So C alone would be a better candidate if you need to consider key. So when you are asked to find candidate key or key, like if you take for example, if you are taking a b c d e f closure, you are actually getting everything. So that is not what you are asked. You are actually asked to find the minimal super keys. That is, ab plus is an example, c is an example. That is, using a and b you can reach all the attributes. Using c alone you can reach all the attributes. So hope you got the concept of functional dependency as well as closure, and how we can find out a candidate key using the concept of closure. Thank you.